Alright, then we'll get into application. Yeah, we're gonna apply the true length lines to solve again true size and shapes. Sticking to the oblique plane still. Yeah, let's get into it. Alright, let's apply the true length line. So the true length line it usually becomes a pointer line. We call it, like a pointer line for a projection, all right, for the next progressive meaning, like it just come, the next projection. Don't worry too much about the adjectives and stuff like that and the language. They're very simple actually, okay? We call the true length line a pointer line, yeah, for the next projection. So this is how you're gonna read by ditching all of the adjectives. English or any language is very bulky to describe the science or mathematics, all right? Problems. So how are we gonna project? We're gonna project in the direction, yeah? Every time you project something, you've got a direction. It means that you're going, yeah? You're going in the orientation of the true length line, and you gotta do that projection parallel to its orientation. We're gonna come to that with a diagram, so you can be able to visualize easily. And then don't forget, you will definitely get an edge view every time a view is projected parallel to the true length line on any planar surface. Okay, and we do the same thing from the edge view. We're going to project it perpendicular projection as we always draw, and that projection is going to produce true size and shape view on the adjacent plane. Yeah, so again, when you read it, you're not going to get it. Yeah, now you get that later, and everything will come to you. Yes, at the end of the semester, I would say the fastest. Usually takes about 6 to a year, to completely understand something. So sometimes some people take about 2 years to get the same thing. Some people take forever and never get it. So that's up to your intelligence. Yes. So anyway, so let's go into the diagram so you can see it. All right. Problem is asking you to solve. Yeah. True size. Give me the true size and shape of a given plane. You're given the top. Yeah. And the front given to you, and you have to usually get the right side out of it. And you've got a slope, right? In your object, we have 1 and then 2 slopes right there. The very first thing you try to find is your edge, view. No edge view right there. So we're dealing with the oblique, and you try to, in your mind, you work it out. If I project it from here to there or from here to there, would I gonna get a line? No, you can't. Right now you can't see it, but the more you draw, you can be able to say right away by looking at the two view. Oh no, I'm not gonna get an edge view. So if you don't get an edge view in any other planes, you're dealing with oblique. Okay, right now the problem is just telling you it is the oblique. So therefore it makes your life easier for you. So we're going to solve the true size and shape of the plane. Okay, so here is the problem recap. So we have to solve the true size and shape of a given plane, and the plane, is oblique to our line of sight because not parallel, not perpendicular, therefore it is oblique. And 2 views are given to you. So first, we're going to verify the projection, as we always do. Starting out, So how do we verify the projection? We're going to connect, the points with the projectors, These are your projectors, and we're going to connect the points. We have only 3 points, in each view. So connect them, all of it. Doesn't matter, you can give 1, 2, 3 or 1, 2, 3 here or 1, 2, 3, Number doesn't matter, just stick to where you put. You can put like 1, 2, 3 here and then 1, 2, 3 there. You can do that. It's got a corresponding. One is corresponding to 1, 3 is corresponding to 3, and 2 is corresponding to 2. And then throw a full line in between, yeah, the two views. And of course, don't forget that full line got to be always perpendicular to your projector line, yeah. The next thing we're gonna do is we're gonna find the true length line. Okay, where's the true length line? I don't know how to find a true length line. So all we have to do is find a line that is parallel to the four lines, yeah? Then find the line that's been projected from that line in the adjacent view. So here you have only, where's my pen? Here we go. So here is this line, see that? And here is your four line. They are parallel to each other. Okay, so we usually put a little 2 mathematics symbol that they're parallel to each other. And then the projection of that in the adjacent view is your front view, yeah? So your line 1, 2, all right? And here is your TL, that's your true length line, yeah? You get it in your front view. Find the line in the top view that is parallel to, in this case it is a top view, right? Find the line that is perpendicular to your full line. Project that line to the next view, which is this guy, and that is your true length line. All right? Find the line parallel to your full view. Project it to the next view. The line that's been projected from that line parallel to the full view, a full line is your true length. All right? Here I put it TL here, and that's on line 1, 2 right there. It's been projected from line 1, 2, yeah? From the top view, which is your horizontal view. Top views are called horizontal views. You have to project it from this line and not 1, 3 or 2, 3, because this line is parallel to the full line. All right, so you got it. So it is not true length in the top view, right? That's not true length in the top view. It's because it's not being projected, yeah? Because there's no line that is parallel to the full line in the front view for us to project it. You can have something that is parallel, yeah? And then it would have been on the other side, okay? For this particular example, the true line is here in the front view, yeah? All right, next one. Okay, so why do we have to identify the true length line? It's because we're going to use that to project, yeah, and get our next view, which is your right side view in this case, because we're given top and front, so we gotta produce the right side view, yeah? And we're of course dealing with the oblique planes. So when we get our next, yeah, right side view, you can be able to get your true size and shape, yeah? Solution of our oblique, dealing with the oblique surfaces. Okay, now we're gonna start with our projectors, yeah? Then we're gonna put a full line perpendicular to these projectors. These are projector lines, yeah? Since this is your true length line, we're gonna draw extended out of it, parallel to that perpendicular full line. We're gonna put it in, yeah? What are we doing? We're gonna draw the last view, which is your right side view for this, yeah, problem. This is just reiterating, yeah? If you the rule of your true length, yes, stating that a projection parallel to a true length line on a surface is going to give you a point of view of the line or an edge view of the plane, okay? So that's just from the previous section of this unit. All right, next one, we're going to identify the middle view. So we have two views, so which one is the middle? This one. Why? Because we have our true length line. We already have projectors and a full line, okay? And this is where we're gonna go to the next view, yeah? So we call this one the middle view because it's situated between the previously given, yeah, view in the problem and the one that we're trying to draw your next view, yeah? So therefore this one is middle or in between the top view and the right side view, yeah? measurement, we are going to take always from all four lines. Yeah, so you have this measurement is taken from that. So since we're drawing a new one, that measurement got to be taken, yeah, from the reference four lines. Reference planes are called the four lines. So your top view, your front view, and we're going to draw our right side view. We're going to transfer measure, yeah, from top to front, from front to the right. So let's start measuring. Pay attention to the points. There's one, there's two, and then there's three. Yeah. This, your projector is there. They're on the same line, so therefore you're gonna get a point here. Yeah. Three single line on this projector. Okay. So you have a single line here. Yeah. We're gonna go back our measurement. The full line. Okay. To the point 3, distant D1. You have the full line, yeah. 2.3 got to be distant D1. Full line, right? 2.2 is distant D2. Your full line. 2.2 right here is distant D2. Okay, so make sure you get all of that. Some of the students measure, yeah, from here to here, and then try to, yes, it has nothing to do with this, but this is just the distance between these two views. So these distances are going to be the same for these two views. All right, so we got to keep the measurement of the object, yeah, which is this guy. Of course, we can see only the horizontal view, which is your top view right here, yeah. But still, between the full line and the point, between the full line and the point, do the same thing between the full line and the point, between the full line and your point, yeah. So we're done with the dimensioning. Continue. We're gonna connect all points, yeah. 2 and 1 are fused right there because they are on the same line, yeah. So when you look at it, yes, this is front. So when you look at it from the right side, you see this and this, yes, as a point, yeah. And we connect it. Now we got the line, yeah, here. We keep our dimension D1, yep, D2 here. So here, what we get is a single line view, yeah. Now we're having an edge view here. That's a line, yeah. So after transferring that perpendicular projector perpendicular to the full line, will always give you a point in that. But you're dealing with, your problem is not inclined, yeah, not inclined planes. We're dealing with the oblique planes. Therefore, we can stop here at the edge view. You gotta produce the entire, yeah, entire projection of the object. So now we have two views right there. So we can leave it here because our problem is not dealing with inclined planes. We're dealing with oblique planes, yeah, because it said it, so your problem stated it, yeah. So this is also where the student make mistake because they are gonna stop right here without projecting more from this point. Yeah, we'll have to project it more. So now we've got the primary auxiliary, which is your edge view, which is, like we usually get this after we transfer the data from the middle view, but we're in a problem of oblique planes, so we have to continue. Okay, then we're gonna recall our rule. Every time you have an edge view, you're gonna project in other direction or this direction or this direction. Doesn't matter which direction you project, you will get the true size and shape. Yeah. So last projecting to this side, yeah, because I have more space here. I don't have a lot of space right there. So I'm gonna project straight. Projecting meaning drawing the projector line from the points, yeah. So we have points here and point right here. So we draw, and then we're gonna put, yes, the full line. So that's what we always do in order for us to produce the next view, yeah. And now you can delete, everything that is not necessary So here you can see, yeah, we're just drawing this, yes, see that, yeah, and then here, and then here, yeah, we're getting rid of everything that we don't need, like dimension stuff, erase it, yes, because we need to make this a space in order for us to draw, yeah, the next view. So delete the full line, which is gone, yeah, and we are going to leave, yeah, so get rid of this one. So, and you can move this line to here a little bit if you want to, yeah, see, and that's our new full line, yes, and we will do the same thing, yeah, this to one from here to here, the same distance, extend it out, yeah, and this 3, of course, that point, yes, got to keep the same distance from 1 and 2, so here, yeah, and here. We are going to close it, yeah, close our projection right there, yes, so you have your 3 right here, yeah, and this one is your 2, okay, and that one is your 1 right there, okay, and keep all the distances between 1 2 1 3 and then 2 3, okay, so 1 2 and 3, so we're gonna put that right there, yeah, 1 2 and 3, and that's a true size and shape. TS and S, TL is a true length line, TS and S is your true, all right, size and shape, just abbreviations. And here is our projection, yes, the last view, okay, so which actually is your right side view, yeah. Do not stop it right here. Why? Because you're dealing with oblique, not inclined. Why is it oblique? Because you didn't get the edge view, yeah, can't get it, and this is not the view, yeah, this is just a projection, primary and auxiliary view. We gotta do this in order for us to transfer that data, yeah, you can't go from here to here without drawing this, okay. All right, let's recap. So we just deal with the getting the primary, which is your edge view, secondary, which is the last view, yeah. We'll go back and show you that's your primary and that's your secondary. Secondary keep the true size and shape. In next section, we're gonna get into oblique problems, yeah, when you have no true length lines, yeah, meaning like we don't have this true length line, yeah, meaning like you don't have a parallel line to the first full line. And we will learn how to deal with those problems in the next section. So how are we going to approach it? We have a two approach, right? First is we do the same thing, solve the problem, create an extra auxiliary view, and you have a line, right? A specific line will be projected in true length. The second one is we're just going to create a true length line within the surface itself. Again, you can't understand it by reading it won't go into your head. You have to look at the diagram, yeah, and a problem to see each one of them how the transfers and projections are drawn and produce the true size and shape. Okay, and that's it for this true length line application for all these surfaces here. Let's talk.